All right, thank you for joining us today as we are on the journey of learning how to evaluate limits on a specific function. When you see this function, now we learned in the previous video how to evaluate what a rational function. Now we are going to add rational function and radical function. Now we have a rational function which involves what? A radical function, right? So that's what I mean. Let's jump right in. So now let's assume we have a rational function. We want to find a limit of a rational function, but this rational function, we have a radical function. What I mean is we have a root function in addition with the rational function. What are we going to do? So it's very simple. Let's take just example. So let's assume that I have limit x is approaching 2, and then I have x minus, let's say, 1 divided by root of, so let me make this one 4, right, so that it will make it nice, like minus 2, right? So we can see that this is a rational function, but we have what? A radical function also right there, right? So the same idea with how we went through the process of what? Rational function. We just plug in the value. If we are getting 0, we simplify, and what? We check the process. But here is a little bit, we need to change something a little bit. So the first thing that we need to do is we need to do direct sub, right? Or we plug in. Then if it doesn't work, then what we are going to do is we are going to find conjugate, right? We are going to find conjugate. Conjugate. Now the conjugate always goes with the function with what? The radical, or the function with root, right? The one, whether the numerator, whether the denominator, the one with the root. That's what we are going to do. So let's first do direct substitution. Now I just use my pen to show it. Now when I put 4 here, root of 4 is 2, right? So I'm going to have 2 minus 2, which is going to give us 0. So automatically the denominator is going to be what? 0. So it means that the direct substitution is not going to work. So the next thing that we need to do is we need to find the conjugate to multiply. We find the conjugate, we simplify, and we plug in, or we do direct substitution. So that's what we are going to do. So now, since direct substitution is not going to work, what can we do? We can find conjugate. So let's try and find conjugate. So limit x minus 1 divided by root of x minus 2. What are we saying? Like, what am I trying to say? Conjugate. Now what I need to do is I pick the one with the root, which is here, then I change the sign in between them. If it is negative, it will change to positive. If it is positive, it will change it to what? Negative. So since this is negative, I'll multiply this function by 1, but not just 1, as we said, 1 by writing the 1 here as root of x plus 2 divided by root of x plus 2. So this is going to help us to, this is actually, when I cancel, this can cancel this and it is 1, right? So that is the idea. So now, since we are done finding the conjugate, we need to simplify before we plug in. So now let's simplify this function before you plug in. And what is the technique here? The technique here is that anytime I find a conjugate and I want to simplify, you see, when you look at the one here, this is having a radical, that is the root. This one too is having the radical, which is the root. It means that anytime I'm working with rational function and a radical function, what I need to do is I always simplify the one with radical here and radical here. I don't simplify the one which has one radical at one side and no radical at the other side. So this one, there is no radical here, so I'm not going to simplify it. With the idea of cancellation, I should be able to cancel some of the function out. So if I do it in a such a way that I cannot, if I simplify it, means that I cannot cancel. Now there is something small that I need to do with the question. This right here should be 4. Yeah, so that one should be 4. Sorry, so that one should be 4. so that we can do the cancellation there. So this one should be 4. So now let's look at how we are going to do it. So I'm not going to simplify the one that has only one radical, but I'll simplify the one with radical. So sometimes we have a question where the radical will be at the top. So you need to simplify the top and leave the denominator, right? So let's do it. Limit x is approaching 4, then I'll multiply. So this times this. I'm not going to simplify, so I'll write it as x minus 4 in parentheses, then root of x plus 2 in parentheses, divided by, good. Now since I have this one here, now I can simplify. So root of x times root of x, what am I going to get? I'm going to have x, right? Then root of x times this guy here will give me plus 2 root of x. Then I'm done multiplying root of x with this and that. So the next step is pick -2 to multiply this, -2 to multiply this one too. So when I do that, I'm going to have -2 root of x, then -2 times 2 will give us -4, right? So now we can see that this and this will cancel out. So it means that we are going to have this and this will cancel out. We are going to have limit x is approaching 4, x minus 4, then root of x plus 2, all divided by, the denominator will be left with x minus 4. Then this will help us to cancel this and this. And as I said, we can only cancel a function at the top and the down when you see that we have two functions. Whenever they are multiplying, when they are adding, we cannot cancel. So for example, we can see that this is multiplying this in parentheses, so it can cancel this. Now let's assume that we have like addition sign here. We cannot cancel. When we have addition sign here, we cannot cancel this and this. So that is what you need to learn. So this is going to be left with limit x is approaching 4, then root of x plus 2. And then now we can after the simplification, we do what? Plug in. So now let's go and do plug in and see. So we are going to have, now I plug the 4 in here. So I'm going to have root of 4 plus 2, and this one will be 2 plus 2, which is going to give us 4. Now note something too here. Anytime I'm writing, you can see that I have my limit, 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 to the point when I'm come to now do the direct substitution when s is equal to what? 4. That's when I don't bring the limit again. So anytime I'm not using this by doing substitution, I need to write my limit. And you can see something nice that I'm doing. You can see that my equal to sign 2 are in line. It makes your work very presentable. Assuming I'm marking your work and you have presented it this way, it makes it more nice. I can even dash you marks. For example, let's assume that the way you are presenting the thing was so nice. For that moment, I will like you. Yes. Wow, that is nice. So I would like you to pass. So for example, if you did well here and you are not doing well the other one, I will try to adjust the mark to make sure that you pass. So that is the idea with how we can combine a limit of a rational function and a radical function. Do direct substitution. If it doesn't work, find a conjugate, simplify, and do direct substitution. In the next video, we are going to talk about how to evaluate a limit when we have trig function. See you.